Welcome to 1.6 Properties. Properties in math are the exact same thing as a fact in science. The reason why we have properties in math is because it will happen every single time. Nobody, no mathematician, scientist, whoever, has ever proved this to be wrong. It will work every single time. I think we need one more explanation point to make that explicitive and let you know that this is a fact. And these are always true. Okay, so if we learn our properties, we now know how to maneuver our numbers. We now know how to combine our numbers. We now know how to find the pattern. And if we ever get stuck, we know what to do next because we know our properties. Let's take a look at the distributive property. The whole point about the distributive property is you're distributing a number through multiplication. And you're distributing that multiplication to either an addition problem or a subtraction problem. So let's talk about what it actually means first. I have a number A outside the parentheses, and I have a problem inside B plus C. What I can do is I can distribute the A. So I can write A times B plus A times C. Now let's see if this works. Well, I already know it works because I already said it's true. But let me give you an example of how it works. If I have 2 times 1 plus 3. There's a couple ways I can do this. I can solve inside the parentheses, and that will give me 2 times 4, and 2 times 4 is 8. Or I can use the distributive property. The reason you want to use the distributive property is because you're going to have variables inside or outside which you can't combine with a constant. So let's use the distributive property. 2 times 1 plus 3. If it works, I should come up with the same answer, which it should work because it's been proven true. So we have 2 times 1 plus, notice my sign is plus, 2 times 3. And then I solve. 2 times 1 is 2. 2 times 3 is 6. And 2 plus 6, because I brought down my addition, is 8. It will be true every single time. All I'm doing is distributing the number on the outside. Now, you can have a left distributive property, which means this number here is on the left side, or you can have taken the same problem, the number on the right side, which will give you the right distributive property. You're going to solve it the exact same way. You're going to still multiply a 2 times 1 plus, and then a 2 times 3. Ooh, there's a 3. Exact same thing. 2 times 1 is 2, plus 2 times 3 is 6, and I still get 8. It doesn't matter if the number variable on the outside of the parentheses is on the left or right. Just so we're clear on that, some books are different. Okay, now let's go to the commutative property. Promise not to laugh at my drawing, please. Okay, I am at home. H for home. I just woke up. I'm going to eat my breakfast, get dressed, brush my teeth, get ready, hopefully take a shower in there somewhere. Okay, get ready for school. I'm going to commute or I'm going to go to school. And I'm going to use S for school. So notice the direction in which it's going is very, very important. At the end of the day, I'm going to commute back home, or I'm going to go to back home. Notice only my direction changed, not my home or my school. Can you imagine if it changed every single day? Oh my goodness. So when we have the commutative property, what it's saying is, even though I drew the arrows, which the arrows are very, very important, you have to ask yourself, am I going from one place to another and then another place back? So when I talk about this, well, what do you mean on the way back? That's what we use the equal sign for. So if I say from A to B, now how am I going to go? Where am I going to start? I'm going to start at home. I'm going to go to school. I'm going to start at school and go home. So I'm using the same variables. I'm using addition. Okay? Not changing anything. I'm just switching the direction I'm going in. I go from A to B and B to A. What that's saying, and this works for addition and multiplication. What this is saying is I can have 1 plus 2 will give me the same answer as 2 plus 1. All I did was switch it, because 1 plus 2 is 3 and 2 plus 1 is 3. It's going to work every single time. Now, it only works for addition and it only works for multiplication. So if I have 3 times 2, it's going to mean the exact same thing as 2 times 3, because 3 times 2 is 6, and I get the same answer as 2 times 3. It doesn't matter which way they're going. It doesn't matter if you're going to school or from school. You're still going to the same places. Okay, so if it only works for addition and multiplication, that means it does not work for division and subtraction. Let's go on to the next property, associative property. I'm going to associate my friends, and I'm going to associate with them. And I'm going to associate with them by using parentheses. So if I have group A, group B, and group C, I'm going to associate with A and B, and I'm going to kind of leave C out. I know it's not really nice, but C's left out. I'm only going to associate with one group at a time. Or I should say with 2 groups at a time. Okay? Can't associate with 3 at a time. I can only associate with 2 at a time. On Tuesday, I come into school. I'm mad at group A. So I'm going to associate with B and C. I'm not going to associate with A. I'm only going to associate with B and C. Take note. I circled who I'm associating with. I never changed the position of the letters. They still go A, B, C, and A, B, C. Once again, this only works for addition and multiplication. So let's take a look at an example. If I have, well, let me give you the associative properties. A plus B plus C will equal A plus B plus C for any given number. So I'm going to associate with A and B, just like I did over here where I circled it. And then the next day, or on the other side of the equation, I'm going to associate with B and C. Notice I did not include that addition sign here. It's A plus B plus C. Okay. Let's make this a little bit darker. I associated with A and B, and on this day, or on this side of the equation, I associate with B and C. Same exact thing for multiplication. If I have A plus B plus C, and I have the exact same thing on this side of the equation, who am I going to associate with? I'm sorry, we just did A plus B. I wanted to show you multiplication. Sorry about that. Where's my B? Okay. Multiplication, 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 multiplication. I'm not going to use the x here in this problem because I don't want to mix it up with a variable x. Okay. Same exact thing. I'm going to associate with A times B, and then on the next day, or the other side of the equation, I'm going to associate with B times C. Let me highlight that. I'm going to associate with A times B, and then I'm going to associate with A plus C, or B plus C. Notice there is a sign. It's not A times B because there's a sign in between the variable and the parentheses. Same with multiplication. I'm going to associate with A times B, and the next day I'm going to associate with B times C. Let's take a look with numbers. I'm going to use 1 plus 2 plus 3. The next day, I'm going to use 1 plus 2 plus 3. Who do I associate with? I associate with 1 plus 2 on this side of the equation, and the next day I'm going to associate with the latter half, or 2 plus 3. Why do I put parentheses around those? The reason I put parentheses around those is because according to order of operations, I always solve inside parentheses first. So if I were to solve this, 1 plus 2 is 3. Now I can solve outside. And 3 plus 3 is 6. On this side of the equation, I have to solve 2 plus 3 first. So 2 plus 3 is 5 plus 1, and 1 plus 5 is 6. And 6 equals 6. The only reason we use the associative property is to show what to solve in what we want to solve inside the parentheses first. And let me show you an example of the associative property here. Same thing. 1 times 2 times 3 equals 1 times 2 times 3. Now I know if I say 1 times 2 is 2 times 3 is 6, 1 times 2 is 2 times 3 is 6. I solved both of them in the exact same order. But when I put my parentheses around them, I now solve in a different order because I solve inside my parentheses first. 1 times 2 is 2 times 3 is 6. That's just a coincidence. That equals 6. Now I have to solve the 2 times 3. 2 times 3 is 6 times 1, and 1 times 6 is 6. You know you did it correctly because it will come out the same number equals the same number. Okay, let's take a look at the identity properties. The identity properties work for addition and multiplication. Identity means if I take a look in the mirror and say, mirror, mirror on the wall, who's the fairest of them all? Mirrors really don't talk. But when you look in a mirror, you see yourself. If I looked into a mirror, I would see me. I would see my identity, exactly what I look like. And that's the whole purpose behind the identity property, is the mathematicians saw a pattern here. They said I can take any number, add 0, and I get that number back. So that would be the identity property of addition. The same with multiplication. If I take any number and multiply it times 1, I'm going to get my identity right back, or I'm going to get the exact same number back. So if I had 6 plus 0, this is just an example, I'm going to get my 6 back. Okay, I'll get the 6 back. If I have any number 6 times 1, same thing. My answer is going to be the exact same. That's why it's called the identity. You need to think of this as a mirror, and you get the identity back. If you think of this as a mirror, the 6 looking into the mirror, you'll get the 6 back. That's what you will see inside the mirror. Okay, let's go ahead and start using some of these. Here I'm not going to solve inside the parentheses first. I want to use distributive property. They're all distributive property. I know they're distributive property and not the associative property because there's no sign right here. There's no sign right here. There's no sign right here. Okay, a lot of kids get that mixed up. So let's go ahead. I'm going to multiply. I'm going to distribute the 4. 4 times 5 plus, now I'm going to distribute 4 times 7. 4 times 7. Notice the 4 is times 5 and the 4 is times 7. 4 times 5, pen's going out on me. 4 times 5 is 20, and 4 times 7 is 28. When I add them, I get a 48. Now let's see if it works the other way. Gotta double check your answer. 4 times 5 plus 7. 4 times, this part I'm going to solve inside. 5 plus 7 is 12, and 4 times 12 is 48. Okay, next one. Here we have a left distributive property because the number we're multiplying both numbers by is right distributive property because it's on the right side. So let's distribute. 2 times 10 plus 2 times 8. And let's solve multiplication first. 2 times 10 is 20, plus 2 times 8 is 16, and 20 plus 16 is 36. Now, I'm going to go back and double check it by solving inside the parentheses. 10 plus 8, and then times 2. I have 18 times 2, and I get 36. Okay. Now, what's different about this one? There's no sign in the middle here, so I'm going to use the distributive properties to solve, but here we have a minus. Okay, notice we add after we multiplied the number on the outside with the numbers on the inside, we always added, and that was because of this sign right here. And so let's take a look at this one. This time, after we multiply, we're going to subtract. I'm going to distribute the 7 times 4 minus 7 times 1. 7 times 4 is 28 minus 7 will give you 21. Now, it should work doing it the other way too. So, 7 times 4 minus 1. If I solve inside the parentheses first, 4 minus 1 is 3, and 7 times 3 is 21. Very good. Let's go on to the next one. Now we're going to name that property. Name that property. We have, that's an I, the distributive property, which is A times B plus C equals you distribute the A, so you have AB plus AC. We have the commutative property, which is if I have A plus B, I can switch them around, and I have B plus A. I have the associative property. If I have an A plus B plus C, I also have an A plus B plus C on this side. I just associate the first two, and then I associate the second two. Nothing changes. And then I have my identity properties, and that tells me if I have a number plus 0, I'm going to get the number back, and if I have a number times 1, I'm also going to get the number back. Okay, let's talk about, now that we did a quick review and we have them up in the corner, we can take a look and see what property we have. I have 3 letters here. I have 3 terms here, a 7 plus 6 plus t. On the other side of the equation, I have 7 plus 6 plus t. Now, the only one that has 3 other than the distributive is the associative. Notice on the associative, the 7, 6t, 7, 6t, no terms, changed positions. I first associated the 6 and the t together, and then I associated the 7 and the 6 together. So this is the associative property. And if you want to get in real detail, it's the associative property of addition. Number 2, 0 plus x gives me x right back. The only property I have to do with 0 is my identity property. And that's because I get my variable right back, the same variable. And the same with this one. 8 times 1 equals 8. I'm getting the 8 right back. Anytime I multiply any number times 1 or any variable times 1, I get it back. So this would be the identity property. Now let's take a look at this one. I have a 5W1. 5, 1, 5, or W1, 5. That changed around. They changed positions. So if I wrote it out like this, if I'm thinking the associative property, because there's 3 terms, I have a 5, a W, and a 1, and then a W, a 1, and a 5. That cannot be the associative because they changed positions. So definitely not the associative. Do I see an operation here? Add, subtract, multiply, or divide? No, I do not. Notice in the associative property, I have an addition here. I have an operation. Okay, so if I see no operation, it automatically means I'm going to multiply. Well, which one of these properties do I multiply? I multiply in the distributive property. So I'm going to distribute the 5. 5W plus 5. And the same with this side. Remember I told you that this is the left distributive property, this is the right distributive property. Doesn't matter which side they're on. If there's no operation, it's automatically assumed it's multiplication. Let's distribute the 5. 5 times W is 5W, and 5 times 1 is 5. My sign inside is plus. Does 5W equal 5W and plus 5 plus 5? Yes, it does. So this would be the distributive property. If you have any questions, ask your teacher, or you can ask them right on YouTube. Okay, let's go on to the next part. Oh, we have one more. We have to identify the property. Wait a second here. I have 3 terms over here, but I only have 1, 2 set of terms over here. What happened? Notice with the parentheses, there's no operation, so I'm going to assume the multiplication. Now, they didn't solve anything over here, but they did move stuff around. They said 7 times 6, and then plus, and then 7 times 2. I distributed the 7. Notice there's a 7 in this term, and there's a 7 in this term. So this would be, even though they didn't solve 6 times 7 or 2 times 7, they still distributed the 7, so therefore it would be the distributive property. Okay, next section. I kind of took the liberty of cutting down the directions. And this no parentheses means I have to take away the parentheses. Okay? We're going to use our properties in order to do that. 7, and then inside parentheses, 5 times x. There's no operation here, so I'm going to assume it's multiplying. So let's go ahead and multiply. I'm going to distribute this 7, so I'm going to use the distributive property. 7 times 5 is 35x. Now, this is considered one term. So it's 7 times the one term. I'm not going to say 7 times 5, 7 times x. I'm going to say 7 times 5x. In this case, all I do is multiply my numbers. And so I get 35x. Okay, here I have 3 terms. I have 2 operations, addition. I need to get rid of the parentheses. I have a 7 plus 3 plus t. I can't combine inside here because I can't add a 3 and a t together. I can multiply them, but they don't want us to multiply them. They want us to add them. So how do I get rid of the parentheses? 7 plus 3 plus t. Okay, remember, in the associative property, my terms don't change. if I can associate a 3 plus t on this side, which are the last two terms, I can associate the 7 and the 3 on this side. Now I can go ahead and solve. 7 plus 3 is 10, and I'm going to rewrite what I have on the outside. 10 plus t. I got rid of the parentheses. Number 3. I have a 9 plus h on the inside. I cannot solve. On the outside of the parentheses, I have a 5 with no operation. So I'm going to assume that's multiplication, which leads me to the distributive property. So let's distribute the 5. 5 times 9. 5 times 9. And then 5 times h with a plus sign in the middle. And so let's go ahead and solve. 5 times 9 is 45, and 5 times h, don't forget your plus sign, is simply 5h. I can't combine these two because they're not the same term. They each don't have an h in there. So I'm done. Okay, let's go on to number 4. I got a couple different operations. Right off the bat, I should say I have parentheses with a number outside the parentheses and no operation. So that means I'm going to multiply. So let's go ahead and distribute. 3 times h plus 3 times 2 minus 2h. Okay, so I distributed the 3 first, and then I'm subtracting 2h. Now, let's go ahead and solve inside the parentheses. 3 times h is simply 3h. Bring down my plus sign. And 3 times 2 is 6 minus 2h. I didn't do anything to the 2h, so I just bring it down. Now I'm going to get out my trusty highlighter. The reason I'm going to do that is because I have two terms that are alike, so I can combine them. I have a positive 3h and a negative 2h. I'm going to change the color of my highlighter because I'm going to only solve, since I'm adding and subtracting, I'm only solving the numbers, not the letters. So 3 minus 2 is 1h. You need to think of that. If I have 3 horses and I take away 2 horses, I have 1 horse left. Now I can't do anything with the plus 6, so I'm just going to bring it down. I think that's when I really started liking algebra. It's like, oh, I can't do anything with it, so I'm just going to bring it straight down. I don't have to solve it. I just bring it down. Now I can write 1h plus 6, or I can just simply write h plus 6. Because this is assumed. If I see 1h, I'm going to assume I only have 1h. If I see 1 horse, I don't have to put a 1 in front of it. I'm just going to assume I have 1 horse. The 1 likes to hide. I can't blame it. I don't like getting my picture taken either. Okay. Once again, if you have any questions, let your teacher know. Let's go on to word problems. This is your favorite. I know. Y'all love word problems. Why do we have to read in math class? Okay. A grocery store sells an imported specialty cheesecake for $11 and its own store-baked cheesecake for $5. Use the distributive property to mentally find the total cost for 6 of each type of cheesecake. Let's go ahead and highlight. Where's my highlighter? Come on, highlighter. Where are you? Can't find my mouse. Okay. I have a specialty cheesecake for $11, and I have a store-baked cheesecake, can't get that straight, for $5. I'm going to buy, I have my $11 plus my $5. If I bought one, but I'm not buying one, I'm buying 6 of them. This is how I know I can distribute. So I can do it one of 2 ways. Let me make this a little bit darker so you can see. Sorry about that. Oh, that's kind of pretty cool. So pretty. I know the boys are like, ew. Okay. I can solve one of 2 ways. I have 2 numbers inside I want to add. I'm multiplying times 6. Now, if I buy one of them, 11 plus 5 is really $16. I don't want to buy one of them. I want to buy 6 of them. So that's like saying I'm going to buy 1, 2, 3, 4, 5, 6, or 6 times 16. 6 times 6 is 36. Carry the 3. 6 times 1 is 6, plus 3 is 9. So I would spend $96. Now, they said use the distributive property. So if you have to explain how you got your answer using the distributive property, you would set up your problem and you'd say, well, if I bought 6 $11 cheesecakes, and then I bought 6 $5 cheesecakes, how many did I buy all together? Or how much money am I going to cost all together? So I'm going to add 6 times 11 is 66. Bring down my addition sign. And 6 times 5 is 30. When I add them together, I get $96. So I did a little bit more than what the problem was asking, but when you're looking for an explanation of how you did it, like I have my kids write in a journal, you would do it this way. Okay? Any questions? Go ahead and ask your teacher. Let's go on to the next one. I have a word problem. I'm going to get out my highlighter. Mr. Kenrick balances his checking account statement each month 2 different ways as shown by the equation. He says B plus D minus C, or B plus D minus C. Notice BDC, BDC, they have not changed. I have an addition, addition, subtraction, subtraction. I associated the B and the D, and then I associated the D and the C. Remember, according to the associative property, wrong page. According to the associative property, you get the same answer. It doesn't matter if you group the A and B together or the B and C together, you get the same answer. It is the same problem on both sides, and that's how you get the same answer. Okay, where B is the previous balance, D is the amount of the deposits made, and C is the amount of the checks written. Name the property that Mr. Kenrick, uses to double check. I just went through and told you. It's the associative property. And I just explained why. So let's go on to the next one. Do we have a next one? Yep. Okay, a train is traveling at a speed of 65 miles per hour. The train travels for 1 hour. what property is used to solve the problem as shown by the statement? Let's see here. 65 times 1 equals 65. I got it back. So that would be the identity problem. Identity property. And what operation am I using? Multiplication. So that would be the multiplicative. They make the word multiplication really complicated. Multiplicative identity property. Okay, notice it has to multiply inside. Thank you for watching. If you have any questions, go ahead and ask them on YouTube. I'll be happy to answer them. Or ask a friend, ask a parent, ask a tutor, ask a teacher. Always ask questions. Thank you for watching.